Assalamualaikum and good day everyone. My name is Wahida binti Azmin and I am joined by my talented team members Atika, Ashikin and Liana. Our project is supervised by technologist Dr. Muhammad Iqmal Fazlan and Associate Professor Dr. K. Dora binti Abdul Ghani. Today, I will present our project title, Preventing the Spread, Crack Arresting Zone for Enhanced Beam Column Joint Performance using R-ECC. Here is a list of contents that I will elaborate more on after this. On 5 June 2021, an earthquake struck Pundasan Sabah, emphasizing the need for resilient structures. R-ECC, a variant of ECC incorporating rubber, enhanced toughness and is ideal for retrofitting applications. Problem statement, current issues. First, a structural failure at the big column junction is a critical and delicate area that has the potential to destroy a building. Second, since structure performance, not strength, is the basis for current dynamic loading, designers are forced to strike a balance between structural ductility and strength. Effects of the issues. The rubberized concrete has primarily limited performance. Second, total failure of the structure can occur from damage to the RC beam column joint. So, what needs to be done? First, increase ductility, decrease brittle failure, and reduce failure of a beam column joint. Second, provide a sustainable method for retrofitting beam column joint using R-ECC. Research question and hypothesis. First, what is crack pattern of RC beam column joint retrofitted with R-ECC jacketing subjected to lateral cyclic loading? Second, how does the load displacement of RC beam column joint react when retrofitted with the R-ECC jacketing subjected to lateral cyclic loading? Third, how effective is the applications of R-ECC jacketing as retrofitting material on the structural performance of RC beam column joint? For hypothesis, first, the use of R-ECC jacketing mitigates and controls the development of crack in the beam column joint, leading to better overall structure performance. Second, the RC beam column joint structures was increased when retrofitted with R-ECC in terms of its high ductility, cracking behavior, deformability, and energy dissipation. Third, R-ECC having high ductility, equivalent viscous damping, deflections, and energy dissipations can improve the structural performance of the RC beam column joint. Okay, next. Our objectives are to investigate crack behavior, evaluate load displacement response, and analyze the ductility and equivalent viscous dampings of beam column joint retrofitted with R-ECC jacketing. Okay, significance of study. In this research, using rubber aligns with Sustainable Development Goals SDG 9 and SDG 11 by promoting green materials and sustainable construction. Scope of study. This study focuses on beam column joint in the Vista Perdana story apartment, particularly their performance under cyclic loading. Okay, next, beam column joint are prepared with dimensions of 150 mm by 150 mm by 705 mm for the beam and 150 mm by 150 mm by 1550 mm for the column. Okay, next, design of beam column joint specimen. The beam column joint are designed according to British Standard 8110 standard with specific dimensions and material properties. The slide shows the retrofitting process involved applying R-ECC to improve the performance of beam column joint. Okay, next, result for maximum crack width. So, retrofitted sample to reduce crack width by 32.21% on the front view and 54.91% on the rear view. So, this result showing significant improvement. Based on the original data, the test is held at a load of 3% drift with a displacement 9.28 mm and for a load of 34.50 kilonewton. By this sample was tested until failure up to 45% with a 52.41 mm of displacement and for a load of 8.43 kilonewton. Result for sample 2 load versus displacement. So the slide showed the hysteresis sample 2 before and after retrofitting. Before retrofitting, sample 2 showed cracking at 0.1% drift and stiffness loss at 2.5%. After retrofitting, it habited delay cracking, reduced stiffness loss, and improved performance. The next result for ductility. So the slide showed the ductility for sample 2 before and after retrofit. Retrofitting enhanced displacement ductility by 7% in the pushing direction, improving the joint's ability to withstand loads. So next result for equivalent viscous damping of sample 2 before and after retrofitting. So equivalent viscous damping was improved with retrofitting, making the joint more resilient under cyclic loading. The slide shows crack video using digital microscope. This video demonstrates crack behavior under load. Retrofitted joints show reduced crack propagation during testing. Novelty of this research: first, R-ECC as retrofitting material in ECC. Second, usage of treated crown rubber in ECC as a partial sand replacement. Third, sustainable development goal S3G9 and S3G11. Next, crack arresting zone CAZ. Cracks are reduced after using R-ECC. Alright, for status of innovation, our research is currently at TRL4 with ongoing efforts to achieve TRL5. Okay, next, benefit to user, society, project, or product impact. So, R-ECC offers improved energy absorption, sustainability, and cost savings in the long terms, especially for earthquake-prone regions. Okay, next about costing, cost-benefit analysis. So, cost comparison show that R-ECC provide better value over time compared to CFRP. Okay, next conclusion. First, the analysis of load versus displacement, ductility, and equivalent viscous damping indicates that the beam collision sample before and after retrofitted with R-ECC can accommodate the applied loading in terms of structural behavior. Second, analysis of the crack behavior of beam column joint with optimum R-ECC through a cyclic load test show that the crack type, which is a flexural crack and shear crack, using 5% of R-ECC shows a positive impact development. And third, R-ECC create a crack arresting zone CAZ that reduce crack length and crack width. For acknowledgement, we acknowledge all contributors and resources referenced in this study. So, as you can see from this slide, TNB Jana Mancho, EPG Engineering Systems Sendirian Berhad, and also Current Incentive Penyelidikan UiTM. Next, the slide shows the certificates of conference and publication. So, our findings have been published in Scopus and ERA Index Journal, showcasing their impact. Alright, these are the key references that supported our research. Okay, that's all from me. Thank you for watching and Assalamualaikum.